First section of notes for today is titled Find the Remaining Factors. Given one factor. First question is x cubed plus 2x squared minus x minus 2. And the factor that is given for the question is x minus 1. What this means is that we have a polynomial. We know one of the factors, one term that factors into the polynomial, and we want to find the remaining factors. What we're going to do for this is basically divide the polynomial by the factor. The easiest way for this question is using synthetic division. X minus 1, the minus 1 changes to a positive 1. Take your leading coefficients, positive 1, positive 2, negative 1, and negative 2. Draw your line underneath, put your plus sign on there, and then divide. The first term drops down. Multiply the number in the box by your answer on the bottom. 1 times 1, which is 1, and that goes underneath the next number. Add straight down. Multiply. Add straight down. And multiply. Add straight down, you get 0, which means no remainder. There's no remainder because it was a factor. Our leftover polynomial, we started with x cubed. This would be x squared plus 3x plus 2. This is the polynomial that's left. What we want to do now is factor this. It is a trinomial. You can factor using the diamond method. 2 goes on top. This is a coefficient of 1, makes it a little easier. Bottom number's 3. Multiplies to get 2, adds to get 3. That would be 2 and 1. So your answer on this one, x plus 2 and x plus 1. So given one factor, the factor we were given is x minus 1, we were able to find the remaining two factors, x plus 2 and x plus 1. Second question is 2x cubed plus 7x squared minus 53x minus 28. And again, a factor given is 2x plus 1. Given this factor, we want to find the remaining factors or factor the rest of the polynomial. Since we have a coefficient in front of x, we cannot use synthetic division, so we must divide this with long division. 2x cubed plus 7x squared minus 53x minus 28. 2x plus 1 is what we're dividing by. 2x into 2x cubed, we need to multiply by x squared. X squared times 2x will be 2x cubed. X squared times 1 will be positive x squared. Best to put parentheses around what we have after we multiply, subtract down. 7x squared minus x squared would be 6x squared. The first term should always cancel. Drop down the next term. 2x into 6x squared, that would be 3x, because 3x times 2x is 6x squared. 3x times 1 is also 3x. Parentheses and subtract. Negative 53 minus 3 is negative 56x. And the last term we drop down, minus 28. 2x into negative 56x. Negative 28. Again, because negative 28 times 2x is negative 56x. And negative 28 times a positive 1 is also negative 28. Subtract down, this will change to positive. Minus a minus is positive. No remainder. And we have what's left over up top. X squared plus 3x minus 28. Again, that's not the answer. We want to find the remaining factors. So just like before, we want to factor this. You can draw your diamond. Negative 28 on top. 3 on the bottom. Multiplies to get negative 28. Adds to get 3. And that would be 7 and negative 4. Since our coefficient of x squared is 1 again, these will be your answers: x plus 7 and x minus 4. So again, given one factor, 2x plus 1, you can find the remaining factors of this polynomial. The next section of notes is titled Solve Equations. And state the number and type of roots. First question is 2x plus 4 equals 10. For each of these questions, we will solve and find the answers, and then we'll state how many answers there are and what type of roots, either real or imaginary. First question, subtract 4 from both sides. Divide by 2. And x equals 3. So the answer to the equation x equals 3, the number of roots is one solution, and it's one real solution. Real because this is a real number, not imaginary. Type of roots is real. So one solution and one real solution. Second question. 2x squared minus 5x plus 12 equals 0. For this question, you can try and factor this trinomial. This trinomial does not factor though. So if you remember from Algebra 1, if it does not factor, to solve this we can use the quadratic equation. Quadratic formula, if you forgot, is negative b plus or minus the square root of b squared minus 4ac all over 2a. To solve this equation, we can plug in a, b, and c and solve from there. A is the first coefficient in front of x squared, b is the coefficient in front of x, and c is the number by itself. Always has to equal 0 when you use the quadratic formula. Negative b would be negative 5, which changes to a positive 5. Plus or minus b squared would be 25 minus 4, a is 2, and c is 12. Divided by 2 times a, and a is 2. Solving this out, we have 5 plus or minus the square root of 25. 4 times 2 is 8. 8 times 12 is 96 with a minus, so negative 96 divided by 4. Simplifying further, 25 minus 96 would be 71 negative divided by 4. When you don't have a perfect square, you can try and do a factor tree. 71 is prime though, so you cannot reduce the square root of 71 or the square root of negative 71. So your answer would stay like that. We also have a negative square root. So if you remember from previous chapters, you can take out the I and you're left with I square root 71 over 4. That is the solution to the equation. The other questions are state the number and type of roots. This question we have two solutions. Plus or minus makes it two solutions. 5 plus I is one solution. 5 minus I is the second solution. They both have I, so they're both imaginary. So two imaginary solutions. So again, the answer to the question is 5 plus or minus I square root 71 over 4, and the number and type of roots is two imaginary solutions. Solve and state the number and type of roots. The next section is state the number of positive real zeros, negative real zeros, or imaginary zeros. There are three types of zeros. They could be positive numbers, negative numbers, or imaginary. The first definition for positive zeros is the number of sign changes or less than by an even number. The number of sign changes is how many times it goes from positive to negative or negative to positive. Less than by an even number, we're basically going to take away 2 from each answer as much as we can. Negative zeros are similar. Number of sign changes, how many times it goes from positive to negative or negative to positive, but of the opposite function, f of negative x. Or less than, again, by an even number, which will be taking away 2. And the last definition, imaginary zeros, remaining zeros that add to the total degree. The degree tells you how many total zeros there are. Whatever the highest exponent is, tells you how many zeros. So whatever is left over has to be imaginary. The first question that will find the type of zeros is f of x equals 5x to the cubed plus 8x squared minus 4x plus 3. For the positive zeros, we will count the sign changes. How many times the function goes from positive to negative or negative to positive. First one goes from positive 5 to positive 8. That's not a sign change because it goes from positive to positive. The next number goes from positive 8 to negative 4. That counts as one sign change, changing from a positive number to a negative number. And also from negative 4 to positive 3. That counts as a sign change because it goes from negative to positive. If it changes twice, there are 2 positive zeros. For the negative zeros, we have to look at f of negative x. What f of negative x is you're going to plug a negative x in for each x value. Basically what that means is when you have an odd power to a negative number, that's going to change the sign. a negative cubed is still going to be negative. But when you plug a negative in squared, a negative times a negative would be positive, and that will keep this positive. For example, if you put a negative in for this x cubed, the answer will be negative, so it will be negative 5x cubed. The next one, when you plug a negative in, negative squared will always be positive, so this will stay the same as positive 8x squared. If you plug a negative in for this x, a negative times a negative would be a positive, so that will change it to a positive 4x. The plus 3 would stay the same, there's no x next to it. A shortcut on this is any odd exponents, you change the sign. Any even exponents stay the same. And now for the negatives. How many negative zeros are there? Again, count these sign changes, how many times it goes from negative to positive or positive to negative. Negative 5 to positive 8 would count as one sign change. Positive 8 to positive 4 does not count, two positive numbers. And also positive 4 to positive 3 does not change. So there's only one negative. One number that is negative that results in a 0 for this function. Also, if we go back to the positive zeros, the last part of the definition says less than by an even number. So if it's 2, it also could be 0. Basically what we're going to do is take away 2 from each answer that we get. If possible, we can take away 2 from here, which would be 0, so we could have 0 positive numbers. The 1 we can't take away 2 from. If there's only one negative answer, there can only be 1. And the last part is imaginary. If we look back at the original question, it's x to the third power, which means there has to be 3 answers to this polynomial, 3 zeros. If we have 2 positive numbers and 1 negative number, that already adds up to 3. So if these 2 add up to 3, then you could have 0 imaginary. You could have 2 positive, 1 negative, and 0 imaginary. Also, though, we have a second answer of 0 up here. If you have 0 positive and 1 negative, that's one answer combined. We need the total 3 answers, which means we also could have 2 imaginary numbers. You could have 0 positive, 1 negative, and 2 imaginary. So the answers on this, there could either be 2 or 0 positive zeros. There has to be 1 negative 0, and imaginary could either be 0 or 2 imaginary zeros. Next example is g of x equals 2x to the 5th plus x to the 4th plus 3x cubed minus 4x squared minus x plus 9. Again, for the positive zeros, count how many sign changes. Positive 2 to positive 1 is not a sign change. Positive 1 to positive 3 does not change. Positive 3 to negative 4, that does change from positive to negative. Negative 4 to negative 1 does not change. And negative 1 to positive 9 does change. So again, 2 sign changes from positive to negative or negative to positive. So there is 2 positive zeros. But again, take away 2 from each answer. It could also be 0. So there could be 2 positive zeros, or there could be no positive zeros. For the negatives, again, you have to do g of negative x. The shortcut method, anytime you have an odd power, x to the 5th, change the sign to negative 2x. Again, that's because if you have a negative to the 5th power, you'll have a negative left over. Any even powers stay the same. And again, that's because if you have a negative to the 4th power, that would still be positive. Odd powers change. Even powers stay the same. X is like x to the 1st, so that's the odd power, which would change. And if it does not have a variable like positive 9, just stays the same. Again, count the sign changes. Negative to positive, positive to negative. Negative to negative doesn't change. Negative to positive does change. And positive to positive does not change. So our negative zeros are 1, 2, and 3. Could be 3 negative zeros, but again, take away 2 from each answer. It could be 3 negatives, or it could be 1 negative. For the imaginary zeros, look back at the original question. X to the 5th means there's 5 possible answers. If we have 2 positive answers and 3 negative answers, those add up to 5, so you have 5 total. So you could have 0 imaginary. 2 positive, 3 negative, adds up to 5.